Welcome back to the workshop for our last video on section 2.8, Bayes theorem. And we're finally to Bayes theorem. Excellent. It's not a very long section, so just this theorem and an example to go along with it, and that's it. So let's take a look at the theorem. So this is, in fact, Bayes theorem. Yay! All right, so if the events B1 through Bk constitute a partition of the sample space S, same thing as we had in the last theorem, and the individual probabilities are not equal to 0, same thing as the last theorem, then for any event A in S such that the probability of A is not equal to 0, so here we're assuming that we can find the probability of A and that it is not 0, then the probability of one of the events BR occurring, the probability that BR occurs given that A has occurred. So this looks a little bit different so far. If we use the actual definition for conditional probability, we would find that this is equal to the probability of B1 and A occurring. Sorry, BR. Let's fix that a moment. The probability of BR occurring, BR and A, divided by the probability of A occurring. Okay, so that's from section 2.6. But what we want to do here is use exactly what we just found, as well as the ideas from section 2.6. So again, theorem 2.9 would tell us that the probability of the intersection is exactly the probability of BR times the probability of A given BR. So now instead of BR given A, I've swapped it. So sometimes the information that you have is convenient for you to perform this particular calculation. Not always. But when it's the case, hey, we have this theorem. And then the probability of A we gave in our last theorem as the sum from 1 to k of the probability of, let's see here, that would be BI times the probability of A given BI. Excellent. With that, we can complete the next problem. So with regard to the first example from this section where we have 3 employees, Larry, Mo, and Curly, they make mistakes every so frequently. What's the probability that a mistake occurs? We did that in the first example. In this example, if a mistake is made in an order, what is the probability that the order was filled by Mo? So we're looking for the probability that Mo filled the order given that there was actually a mistake. Okay, we found the probability that there's a mistake given that Mo filled the order. We know that from the problem. That's given. Mo makes a mistake 6 out of every 100 times. But here we're saying we know there's a mistake that was made. What's the probability that Mo made a mistake? All right. So here, this is what we're trying to find. In example 2.8.1, we found the probability that there's a mistake made as the sum from I equals 1 to 3. Well, no need to write it in this notation, right? We already performed this calculation, and we found that to be 0.315. Oh, in fact, 0.0315. There we go. So we already found that probability. We did this calculation. Let's see here, the probability that Mo filled the order times the probability that there's a mistake given that Mo filled the order. We had already calculated that as well. Let's see here. So probability mistake given Mo, here we go, 0.35 times 0.06. And we can find that to be 0.021. Excellent. So we have the denominator, we have the numerator. We already calculated the denominator in the first example, so I didn't see a reason to go through and do it all again. Okay, so the probability of a mistake, sorry, the probability of Mo having filled the order, given that we know there was a mistake, is given by 0.021 divided by 0.0315. So in this case, what we're actually doing, the computation that we're doing is no different than what we gave in section 2.6 for conditional probability. It's just how we found the value of the numerator and how we found the value of the denominator are different. And Bayes' theorem is just saying this representation. Okay, we're just using this way to calculate the conditional probability. So we already calculated that numerator here. All right, that's the numerator. We calculated the denominator in the previous or in the first example. So denominator and numerator, we found them. So now it looks just like the definition for conditional probability, and we get 0.6 repeating. So to answer the question that was asked, what's the probability that Mo filled the order given that there was a mistake made? The probability that Mo filled the order given that a mistake was made is, might be nicer to just call it 2/3 in this case. And that's it. Excellent. So if you still have any questions or are uncertain of how to use that theorem, feel free to let me know. I'll see if we can come up with some additional examples. But of course, you should always consider the textbook, which contains examples that are different than the ones we give here in our videos. So I'll see you guys back in the workshop a little bit later as we move on to chapter 3, right? So enjoy a small break. Not really much of a break, just light this week. So I'll see you guys later for chapter 3.